Hi, my name is Phil Bagg, and in this video we're going to look at count controlled loops in Scratch. This video goes after the one on count controlled loops, which I recommend you watch first. Our first key point is to model initialization. Now, initialization is code written to ensure that your programming project runs the same way every time. It sets the sprite back to where it was and how it was before the code will run. Initialization blocks wipe out the effects of previously running the code. Let's have a look at some examples in Scratch. Here we have an example that is a piece of code that is designed to draw a square. Let's run the code and see what it does first of all. Of course, we can run the code by pressing the A key, or we can actually just left click on the code. And there we go. You can see that it's drawing a square. Okay, so the initialization are these blocks at the top here. These blocks which set things back to what they were originally. Okay, erasing all the code, all previous lines, deciding what sort of pen color you want to make it, setting the pen size to 3, maybe it's been set to something else earlier, maybe the pen color has been changed to something else earlier. So these are initialization blocks really. You could probably include that pen down in there as well as part of that initialization. Here we have a simple piece of code which is just designed to make the balloon change color. So let's click on the balloon and you'll see it goes from yellow to purple to blue. In yellow, purple, it's repeating this sort of pattern. So let's have a look at what is initialization in here. Well, first of all, we've got the go to X and Y block. That's just in case children decide to pick up this, move it somewhere else. Okay, and then this time when we click it, you'll see that it returns back to its original place. It keeps the code nice and tidy, sending it back to the original place. You'll also notice that because there are 5 repeat loops here and there are only 3 costumes, it's ending up on the purple one. So what we've got here is this little initialization code here of switch costume to balloon 1A, which means it always goes back and starts with that blue block every time. So the order is the same way around each time. Now there may be times that you don't want it to actually go back and start afresh each time from the same costume, but if you do, then actually that's a really useful bit of initialization there. If we don't model initialization, if we don't talk about it, if we don't say why we do these things, then actually pupils won't use it in their own code. Now let's look at processor speed. An average computer processor handles 2,000 million instructions per second. That's a massive number, isn't it? A count controlled loop in Scratch is reduced to run at approximately 30 loops per second. That's still very fast. And so of course there are certain things which are really important. Let's have a look at this in code. Now here we are back with our balloon example that we had a little look at earlier. And of course when we run this code, we've changed the number of beats this time, so it's going to cycle through those 3 colors, those 3 color costumes 20 times. Okay, now watch what happens if we take out the wait 1 second here. Okay, which is giving us time to actually look and visually recognize the different colors. So let me now click on this blue balloon again. You see how quickly that flashes through all of those different costumes without the wait. But we still are seeing them, and one of the reasons we are seeing them or registering them briefly is because Scratch has reduced the number of repeats, the number of actions acted on inside this repeat loop to just 30 per second. In the balloon next to it, we've created a bit of code with just simple sequence really, lots and lots of next costumes. Okay, and let's click on that and see what happens there. Can you see that although I've clicked on it, we've seen no changes whatsoever? That's because Scratch is operating the code outside that simple count controlled loop much faster, much closer to the original computer's processing speed. The important thing to learn here is the importance of weights in loops as well, slowing things down, allowing us to actually see what's happening. But weights are not just good for actually being able to see what's going on inside a piece of code. They're quite educational, because slowing down the code allows pupils to trace the order the code is running in. It enables better comprehension and easier debugging. Let's have a look at an example of this in code. Here is our square that we drew earlier. And actually you might think that the weights are in here to make the program better, but actually they're not. In some way they're actually slowing the program down and making it a little bit less efficient. But they're great for allowing pupils time to be able to see precisely what the different instructions do and when they do them as well. So in here they're really here to be educational, to help the pupils with debugging and fixing and finding problems in the code. In fact, if you were working with a child and they were struggling with this, to see this, you might want to increase the amount of time that it takes to actually draw those things and turn, so that they can actually point to the block and think about exactly what's happening in each stage of that. You might also want to do something like drawing the flow of control over this as well, just to help a pupil see what's actually happening inside that loop. Our last point today really is just to say that longer scripts often need more scaffolding. If we're teaching literacy, we often break up longer reading texts into paragraphs or separate pages to make it easier to digest or understand. And actually we can use these things called sub-goal labels to help with this in code as well. So we're just going to go and show you a simple example in the code. Here we have a program called Come Back Doggy, and what we have done is it's a bit more complex than the other programs we've used, because it uses two count controlled loops, one after the other. So what we've done is put these labels here just to point out what different bits of the code do. These are called sub-goal labels really. A bit on initialization, a bit on introducing the program, a bit on pointing out that this section of code here is about drawing a line, okay, a yellow line in this case, and this bit is about drawing a red line. So it's not all of it, but it just gives us an overview of what that section of code is doing. Another way of doing that, if you're working individually with a pupil, is actually just to take away blocks of code so that you can focus on a bit at a time. We'll often do that with children in class, won't we, where we cover over some questions and just focus on the question we're working on. Okay, and you can do the same thing in code as well. You can block it and ask the children, well, what's happening here? Okay, and let's just have a look at just this little bit of code in here, and then don't forget to snap it all back together again to get the sort of fullness of it as well. Let's run this little program and see what's happening. So we've got that initialization, then the introduction. Now we're going into that yellow bit of code where it's drawing that pen and using the loop to move, and there we go, it's drawing a red pen line, and also using the loop to move as well. The dog, by the way, has just got a wait until command in there, so that they're waiting until the girl actually catches up to them. Let's summarize what we've learnt. Initialization is really useful to be modeled. Scratch allows 30 loops per second in a count controlled loop. Weights are very useful and can definitely be educational to slow a program down so pupils can debug it, fix things and think about it. And it's worth using sub-goal labels to scaffold longer scripts as well. Thank you for listening. My contact details are here. I welcome any questions. In HIAS, Hampshire inspectors provide resources on every area of the curriculum that you can find on our Moodle. You're welcome to subscribe if you're inside or outside of Hampshire. Thanks for listening.